Welcome to the demo of the software integration testing tool ITOsolution. ITOsolution is a powerful tool that can provide integration test order solutions using a cost-benefit analysis. For an object-oriented software system, we define the risk index of a class as a combination of three factors: threat, vulnerability, and failure consequence. Accordingly, classes with high risk indexes are considered as primary test focus, and as such should be given higher priority. Cost-benefit analysis is used to perform breaking cycle operations, which satisfies two principles: assigning to higher priority to high-risk classes and minimizing the total complexity of test steps. Firstly, you should make sure that you have downloaded the runnable jar file. Also, the integration operations need the compiled jar files and source files of the software system to be analyzed. In this video, we take the open source software as an example to illustrate the analyzing process. The links are provided on the bottom of the screen. Press the first button and select the path of the jar files. In this way, the tool can analyze the abstract syntax tree of code. Execute the loading source files operation. The operators and operands of source code can be extracted to evaluate its complexity based on Hofstad measurements. According to a series of dynamic execution scenarios, the software system is mapped into a modular dynamic execution network model, whose abbreviation is MDEN. More accurately, each network layer corresponds to a function profile of system triggered by users. In each function profile, methods or attributes are described as nodes, and dependencies between them are denoted as edges. Furthermore, by zooming in and out of the networks or adjusting the layout, we can take a close look at its structure. The threat measurement means the likelihood of this class being triggered in various execution scenarios. Higher threat value reflects its higher execution probability. Also, ITOsolution allows users to rank the classes based on this measurement. Similarly, the vulnerability and failure consequence denotes the fault proneness of this class and its failure consequence respectively. Then the product of T, V, and C equals the class risk index. In this manner, this tool provides useful means for identifying potentially troublesome classes that require higher priority and efforts during the integration testing process. The results indicate that risk indexes of classes in the system follow a Pareto distribution. In other words, only a limited fraction of nodes have relatively high fault rates and the capability of error propagation. Therefore, they should be tested as early as possible. By removing the edges that brings more benefits to the testing, we eliminate all the cycles from the system. The established test steps are listed in the table. Here, A and B represent the coefficients of the attributes and methods defined in steps. By default, we treated the number of attributes and methods to be emulated at the same efforts for testers. However, there's additional functionality to allow users to adjust the parameters according to their preferences. More importantly, users can also save the raw data such as the class diagram, class dependency matrix, attribute coupling matrix, and method coupling matrix for further replication and research purpose. Finally, the integration test order is obtained. Under the condition of limited resources, try to satisfy the needs of classes with higher benefit rates while testing the others slightly. Obviously, a more efficient integration test order leads to a lower residual amount, a higher reduction rate of system risk. As a result, both the residual amount and the risk reduction rate can be considered as evaluation criteria for integration test orders. Here, the tool also provides the one-key integration function. Press this button, all the results are generated automatically. Clear all the variables and windows, we can analyze a new software system. Thank you for watching our demo.